Okay, logical bus topology is when you might have a network physically laid out in a different sense, but it's logically like working like a bus. And when you look at how different ways you're looking at the actual network flow, there are different examples I'm going to go through where you might have it physically laid out in one sense, but it might be logically working more like a bus. So let's go through 3 examples for you. So if you look at hardware, so let's take a star topology. The central point that we've always thought of in star topology is a hub or a switch. So if you've looked into them in detail, you know that a switch is quite a clever bit of kit, which will look at the packet's IP address header information and direct it in the right, sort of down the right path, which obviously improves security and is generally much faster because everybody the different cables are only used when needed, which means that the flow of information can be quicker. So all these things. However, you could also whack a hub, which is a different bit of hardware, into the central point, that star, and it is still, the network will still work. It's still a star network. The downsides of having a hub is all a hub does is repeat information. So you pass it information and it will repeat it in all directions. Now the downsides of that is the security goes down. But it also means when one computer communicates, you're actually taking up all of the network cabling and communication. So you're taking up all of it, not enabling other computers to communicate. Now that's okay, but that is actually logically working more like a bus, because a bus network, we know, has that backbone and it can only be used by one device at a time, and everybody is receiving all information, which is security flaws. If you put a hub at the central point of a star, that is also logically working like a bus, even though you physically got it laid out as a star. Another example is on all network topologies, you can do this thing called broadcasting. So there's a special IP address that you can use to communicate with every other device on the network, and that's known as the broadcast address. When you are broadcasting on any topology, it is not necessarily physically working like the topology is. Okay, so because if you, again, we'll go for physically a mesh or physically a star. If you broadcast on it, it's logically working like a bus. And the final one, token passing. So the most common way this is taught is in a token ring network, but the concept is can be applied to other topologies as well. But this is where you've got like an electronic token. The way I describe this is, if you've ever played poker, it's like having the dealer chip. So what happens is this token gets passed around, and you can only use the network when you've got that token. Okay, but again, when you've got that token, you then are dominating the whole network at that time, because nobody else can communicate while you've got that token. So you've got to wait for your token to then use that network. Again, if you introduce token passing in a topology, you could argue that it is working more like a token ring, or again like a bus, because of you are dominating all of the communication mediums at that time, because nobody else can use it, which isn't how some of them physically are laid out to enable you to not do that, but depending on the way you set it up, it could still be doing that. Okay, so I know that's quite a hard concept to get your head around, but this is just an idea of how you can have a physical topology laid out in one way, but when you actually look at how the network's flowing around, it logically might be working more like another.